Hello, ladies and gentlemen. My name is Kurt, and welcome back to Space Engine. This is the free-to-download universe simulator. It's quite gorgeous and quite epic in its scale and awesomeness. I've been in this program a few times talking about astronomy things, and today, on what us Americans are calling Thanksgiving Day, on November 28th, 2013, there is a very interesting astronomy event going on. Of course, right now we're looking at Earth. The current time is actually the time I'm recording this as the simulated time in Space Engine. As you can see, the 27th, 20 hours. That's probably GMT time. Yeah, 20, 21, 45. In the lower left-hand corner you can see. But we're going to turn around here and look at the sun from the Earth's point of view. We've got some cool northern lights going on there, as you can hopefully see. Some Michael Bay lens flare effects happening as well. But very interesting astronomy news is happening in that we have a comet, Comet ISON, one that I actually introduced a while ago when it was first discovered last year, being touted as the comet of the century and whatnot, is actually going to make its closest pass to the sun today, Thanksgiving Day, the 28th of November, at about, where are my notes, 18:25 GMT, that's 11:25 AM EST. It's going to make its closest pass to the sun, and that will determine if it survives that. That will determine whether or not it comes out the other side and is as bright as it would be predicted, potentially visible in the daytime. Who knows? We'll have to wait and see. That's what we're all waiting for, I suppose, today, but I'd like to talk a little bit about it, and thankfully, Space Engine, even though there hasn't been any major updates to Space Engine includes comets and Comet ISON. And you're probably wondering, is that Comet ISON right there? I just selected it? No, it's not. Coincidentally, there's also a second comet, Comet Encke, E-N-C-K-E, is also going around the sun at the same time. Not related at all. This is actually, Comet Encke is a very periodic comet, orbits the sun once every 3.3 years, Earth years, I should say. It's just strange coincidence that it's going in at the same time as Comet ISON. Let me look for Comet ISON, actually. The way this Space Engine renders things and has all these lens flares and different effects can affect the way you can see things. Let's actually look for, how do you do that? Yes, ISON, Comet ISON. Okay, there it is. It's much closer to the sun right now as I'm recording this, but let's go to Comet ISON and see what she's up to. And then we'll do a little time fast forward to see what happens as it gets closer to the sun. As you can see, Comet Encke is actually doesn't get too close to the sun, just a little bit within Mercury's orbit. But as you can see, here is the game's Space Engine's representation of Comet ISON. It actually, this nucleus, the rocky part, the the Tootsie Roll Center is about only 2 kilometers across, 1.2 miles about. That's the estimates coming from the observations from Hubble. So relatively small as far as a comet is concerned. They have this nucleus, that's where all the material, the ice and dust is being ablated and off into the from the sun, both from the sun's, the solar wind, but also the light, the actual light. And that's why I think they did a good job. You can kind of see the 2 tails. One of them is from the solar wind, and the other one, very faint green one, you can kind of see it. I hope this translates. There we go. That's a much better angle I've got on the two tails. One of them is due to the solar wind, and the other is due to the actual opposite the direction of the sun, the light, the actual, radiation, I suppose you could say. I don't know if it's technically the radiation. I should fact check that, but comets usually have these 2 tails, and they're not even technically coming from the direction the comet is orbiting, and I can show you that by turning on the orbits. It's actually orbiting around this way. Let me back up a little bit. Actually, let me back up a bit. We're coming out of the solar system. There's Mercury, Earth, Mars orbits. And you can see that Comet ISON, also known as C2012 S1, came from the Oort cloud. This comet is not a regular comet. This is the first and last time it will be visiting us here in the center of the solar system. It came from way, way out. See, they don't even complete the orbit. Way out in the Oort cloud, where there's a bunch of little rocky debris from the creation of the solar system. From, it maybe got nudged. Perhaps another passing star some billions years ago created a little bit of a gravitational disturbance and pushed ISON towards the center of our solar system. And it made that billion-year trip and is now finally and for the last time making its way towards the center, as opposed to right through. As opposed to, if I can select Enki, we can see how different the orbit is of Enki. Yeah, it's pretty much a very regular comet. Enki is goes out just to about the orbit of Jupiter and then back in. Not too crazy as far as Enki is concerned. Just happened to be passing about the same time as ISON. Now let's try to select ISON once again. For some reason, it makes this space engine makes Enki much brighter, which isn't true than ISON. Enki gets at its brightest magnitude 7, positive 7. Whereas right now, even before it reaches its closest approach to the sun, ISON is about a magnitude 1 to a magnitude 0.5, which is about the same magnitude as Mercury is in our night sky. So getting brighter. Of course, it's right now so close to the sun that it's very difficult to see even in the east during the sunrise. There have been many pictures and things. It hasn't. I'm trying to say there's so much speculation. It could be totally amazing, or it could just be a total flop and disintegrate, and we'll not see it come out the other side. Let's try to find ISON again. Whoops, there it is. All right, there's the orbit of ISON. Let's zoom in once again. Come on, a little bit slower. We need a faster spaceship. What other facts about ISON can I have? It right now is traveling 240,000 miles per hour relative to the sun, so that's the speed at which it's approaching. And if we've learned anything from Kerbal Space Program, on the periapsis of an orbit, it gets faster and faster, so it's going to increase speed up to the point where it would be as fast enough to cross from the west to the east coast of the United States in less than 15 seconds. So that is a spicy meatball, but we're actually going to simulate what is going to happen if I can do this without screwing it up. Let me turn off the orbits to make things a little bit more spectacular. As you can see anyway, it's right now well within... Well, right now, yesterday when I'm recording this, well within the orbit of Mercury, and it's going to get about within one solar diameter of the sun. So if you had two suns and put them next to each other, that's how close to the original sun ISON is going to be. So pretty crazy. Let me once again turn off the orbits and let me get close enough to where we can just fly right through it. Come on, easy, easy. There we go. All right, now we can finally see the tail. And let's follow ISON, and let's speed up time a little bit. How do I do that? L? Yes! L, and the time scale is increasing. And as you can see, as it gets closer, and now it is about to turn over to the 28th of November right now, and we're waiting for the magic number is 1825 on the hour and minute. I could probably speed it up a little bit more. We're up to 6. And as you can see, I'm backing away. The tail grows in size as it gets closer. 12, 13, 14, 15. I'm going to slow things down a little bit. 16, 17, And 18, and it really sped up there. 18:15 this is. So we're about 10 minutes out in this simulation from the closest approach. And as you can see, you could barely fit another sun in between where Comet ISON and the surface of the sun is going to be. That is incredibly close, which is why it's such a major problem predicting what will happen with the nucleus. If the nucleus disappears, evaporates, breaks apart, there's not much that's to survive on the other side to make this amazing tale. But as you can see, I believe Space Engine is taking the very optimistic approach to how bright the comet will get, and look at how bright it made the tail and long from this distance. So this is the very optimistic, like if this was to be the comet to end all comets, that is how long the tail is being estimated. And of course, like I said, Space Engine does kind of add a little bit of theatrics as far as the brightness of objects and whatnot. But this is as close as, let's actually find out from the surface of ISON what this would look like if you were to be able to stand on the surface and have some sort of, heat protection, SPF 1 billion, to save yourself from being this close to the sun. All right, let's go here. Yoink. All right. And this is, of course, again, just a simulation of what potentially the comet would look like. I think Space Engine also included, as the time goes on, the actual model of this comet is going to shrink and lose mass and size, which is kind of cool. So yes, that would be an interesting sight indeed. Getting this close to the sun, I imagine it would actually be... Hold on, there are some options to make the brightness even crazier. Here we go. It would probably actually be... Oh, it's too close. You're too close, man. All right, I was gonna try to make it super duper bright and whatnot, but that didn't work. Dang it! Yeah, that would be a crazy thing indeed. I think I can actually land on the surface. Yep, bonk. So here we are on the surface of ISON, looking at the sunrise. Oh, brother, indeed. So let's take off from here once again. And whoop. There we go. So yeah, this is an optimistic representation of what would happen to the brightness of ISON. Like I said, this is going to happen. I'm going to try to get this video up before it happens, obviously, but it's going to happen at 18:25 GMT on November 28th. That is 11:25 a.m. Eastern Standard Time, 12:25 p.m. Central Standard Time. Let's see, I talked about Comet Enki, which it's kind of coincidentally coming in at the same time. Let's see, the tail, right now the tail, a day before its closest approach, is measured to be at least 8 million kilometers, or about 5 million miles long, which is 20 times the distance between the moon and the Earth. And if these predictions are to be correct, and things are going to get pretty crazy, it'll be much, much longer than that. And we can actually... Oh, I have an idea. Let's go back home. Let's go to Earth. Okay. Center. And go to. And we'll watch from Earth orbit what Space Engine is predicting, or would optimistically say ISON would look like, say, if you were above Earth orbit. Of course, if it does survive, I suppose, as a little tip, if it does survive, if ISON does survive the trip around the sun, it has been, before it has gone towards the sun, it has been only visible in the east before sunrise. After, of course, it wings around the side of the sun, it's going to go around the north side, and then it's going to be visible... when is it going to be visible? It will be visible in the east before sunrise in the morning, as well as in the west after sunset in the evening, because it is going to go north, and just like the North Star always stays in the same place, it kind of becomes circumpolar. It's going to be visible on both sides, so that would be very good. So yeah, here we are. That is what at least Space Engine is assuming is going to be... I mean, obviously the Milky Way isn't even that bright. Let me see if I can, like, turn down some of this stuff to be a little bit more realistic. No, that sort of didn't do anything. How about let's make galaxies not so bright? I know there's an option for that. No, that's not going to do it. The sun explodes. Okay, yeah, wow. Oh, okay, the stars went through. Oh well, it'll be fancy and theatrical. No, there's nothing I can do to make the Milky Way a little bit darker. All right, regardless, let's do the fast forward time thing once again, and just watch. Actually, you know what? While we're here, let me actually reverse time a little bit, and we'll kind of watch. All right, we're going back. I'm going to go back to about the time I'm recording this, which is about... let's say around here. Yeah, it's about a little bit earlier. But if I then reverse the time, as you can see, spins around and gets really bright, and then as it gets further away, it dims again. So that is kind of a cool little representation. Again, this is just a simulation. We have no idea what is going to actually be the case. This is in reverse. That would be amazing if that happened. Again, we're going to be learning a lot from this. We've never had a comet that we've known about come from such a far distance in the solar system and get so close to the sun. So, you know, with all these science instruments, we'll be able to observe and figure out what the makeup of ISON is, and then that can figure out the makeup of the early solar system before the planets formed, or even the sun formed for that matter. So it's a really cool moment in astronomical time. And if you want to keep following along, a good website is spaceweather.com. They have a whole gallery of professional and amateur astronomy photographs of ISON. Also, they keep track of all of the major satellites that have eyes on ISON, you know, including NASA's Stereo spacecraft. There's actually 2 spacecraft, one in front and one on the other side of the sun. They observe the sun, but since they're kind of equidistant in front of the Earth and behind the Earth, they actually get pictures of both sides and like a 360-degree view of the sun. So that'll be really cool to see from their point of view what happens to ISON. And they're actually already in the field of view. You can see them. These are kind of the spacecraft and the images. You see the cool CMEs and stuff, and different things coming away from the sun. The coronal mass ejections, I should clarify. Those are the satellites you get this from. Also, NASA's SOHO spacecraft is another one where you can see ISON. And of course, hopefully, if it survives, you can see it for yourself in the morning and or evening times, just after sunset or just before sunrise, excuse me. Hopefully it survives. There's also, I'll put a link in the video description for a Google Plus NASA Google Plus Hangout. Thanksgiving Day, today, the 28th, that starts at 1800 GMT, which is about 25 minutes before its closest approach. There's a bunch of scientists, NASA people. Also, the way I heard about this was Phil Plait, Dr. Phil Plait, the Bad Astronomer blog. He's going to be attending that as well. So I'll put a link to that. I'm not involved in that whatsoever, by the way. NASA has not invited Kurt J. Mack to be part of their hangout, so this is my little contribution. I think I got everything. I have my little notepad. I got through all the notes. I did get a few requests to do this, but kind of a cool thing. And of course, this is Space Engine. Also, a link in the video description to Space Engine if you'd like to load this up on your computer. Kind of requires, there's graphical options, but it kind of requires a little bit of a powerful computer. You know, nothing space age. I built my computer about 1.5 years ago, so you should be all right. You know, so you can fly around and mess around and see what's up with Comet ISON yourself and the rest of the universe, for that matter. Indeed. So yeah, thank you very much for watching. Leave a like if you enjoy this kind of stuff, and I'll try to get back into doing more of the astronomy, the amazing universe stuff I'm always interested in. It seems like you guys are interested in. Indeed. My name is Kurt. Thanks so much for watching. I will see you next time.